All right, today we're diving into one of SQL's real superpowers. We're talking about the magic of taking a massive pile of raw data and crunching it down into one single powerful insight. Let's jump right in.
So you've probably felt this before, right? You're just staring at this spreadsheet or database table with thousands, maybe even millions of rows, and you feel like you're drowning. It's just noise. How in the world do you find the actual story hidden in there?
Well, this is exactly where SQL comes in and really shines. It gives you the tools to take that overwhelming sea of data and just distill it. You can boil it all down to one simple, meaningful number. Think about it, an average, a total, or just a basic count.
And the tools that do this heavy lifting? They're called aggregate functions. Seriously, you should think of these as the absolute workhorses of data analysis in SQL. When it comes to making sense of huge data sets, they're going to be your best friend.
So what is an aggregate function when you get right down to it? The definition is actually pretty straightforward. It's a function that just grabs a bunch of values from multiple rows, does some math, and then spits out one single summary value. It basically collapses a whole column of numbers into one.
Okay, so there are a bunch of these aggregate functions out there. But honestly, you don't need to know all of them to get started. We're going to focus on the 5 absolute essentials, the ones that'll handle like 90% of what you'll ever need to do. Let's build out your core analytics toolkit. And here they are. The core 5. You've got AVG for, well, the average. Count to just count how many things there are. Min and max are perfect for finding the lowest and highest values, the extremes. And, of course, sum to just add everything up. I'm telling you, with just these 5, you can answer a huge range of questions. All right, now let's zoom in on one of those. Count. Because this one function reveals probably the single most important distinction you need to know about aggregates. This is a little detail that trips up even seasoned analysts, so it's absolutely crucial we get this right.
Okay, here it is, the big difference. You have count asterisk. That little asterisk means everything, and it does just what it says. It counts every single row in your group, period. But then you have count column. This one's a bit more picky. It only counts the rows where that specific column actually has a value. It totally ignores any of those empty or null values.
To make this crystal clear, let's look at a super simple example. Imagine a table of student scores. We've got 5 students here, but take a look. One of them has a null score. Maybe they were sick that day, who knows. The point is, their score is missing.
So if we run count asterisk on this table, what do we get? We get 5. Makes sense, right? It doesn't care what's in the rows, it just sees that 5 rows exist. That's it.
But now, watch what happens when we run count score. The result is 4. See what happened? SQL looked down that score column, it saw that null value, and it just skipped right over it. That, right there, is that critical difference in action.
You know, this whole thing leads us to another key concept, the direction that functions operate in. Some functions work down a column across many rows. Others work across the columns but within a single row. This is the big difference between aggregate and what we call scalar functions.
So think of our aggregate functions like min or max as working vertically. They travel down a column. They look at all the different rows for that one column to find a single answer. You know, like finding the single lowest score in the whole class, or the highest salary in the entire company. Scalar functions, on the other hand, they work horizontally. They stay inside one single row and look across the different columns to find an answer. For instance, imagine trying to find the best score for one student across their math, science, and history tests. You're looking left and right, not up and down.
So let's just nail this down. Min goes down, across the rows. That's an aggregate function. Least goes across, within a single row. That's a scalar function. Getting this vertical versus horizontal idea straight is so important for making sure you get the answers you're actually looking for.
All right, time to bring it all home. We've talked about the core functions, we've untangled that whole count situation, and we've looked at the difference between vertical and horizontal operations. Now let's put it all side by side and see how it all stacks up.
Take a look at this table, and pay close attention to that column about nulls. Do you see the pattern? Pretty much every function we've talked about, average, min, max, sum, and count column, they all exclude nulls. They just ignore them. The one and only exception is our friend count asterisk, and that's only because its job is just to count rows, no matter what's inside them.
And this brings us to a really critical warning. This is a classic trap that a lot of people fall into. You might think that taking the sum of a column and dividing it by count star would give you the average, right? Nope. It's not the same as just using AVG function. Why? Because AVG ignores nulls in its calculation, but count star includes the rows with nulls in its count. You can end up with two totally different answers, and one of them is probably wrong. So the big lesson here is always be aware of how nulls are playing into your math.
Okay, so let's do a super quick recap. What are the big things to remember? First, aggregate functions are your go-to tools for boiling down lots of data into a single summary. Second, you have to know the difference between count asterisk, which counts all rows, and count column, which only counts non-empty ones. Third, remember that aggregate functions work vertically down a column, while scalar functions work horizontally across a row. And last, but definitely not least, always watch out for those nulls. They change everything. So there you have it. You now have the fundamental toolkit, the superpowers, to start summarizing and actually understanding pretty much any data set that's thrown your way. So the only real question left is, what's the first story your data is waiting to tell you?